Nitin, sorry to
Yeah,
interrupt. I have
see,
one question. So,
yeah.
you are sharing this link in the video, right? So, while I go through the video, अगर मैं ये URL अगर चाहूँ तो like how do I get it? Or
आपको
is
कुछ
there
नहीं
any
करना
way?
है। आपको कुछ नहीं करना है। Let's say in that video, if I've shared that link, so that means I must have gone through with this problem in the class only. Fine.
Okay.
So
Okay.
you just have to type lead code 141.
Oh, okay.
Fine, and you'll be able to get that question. See the first question. Fine.
Okay. Okay.
So
Understood.
just copy the number of that lead code question and start with that.
Fine. Okay. Got it.
Yeah,
Thanks.
yeah. Now read the question. Yeah, I think Shrutika, you have just joined, right? So I'm sharing the question once again. So this is the question which we'll be starting with, right? Okay. Is there anyone who can explain me this question, like what we have to do exactly? I don't want the solution. I don't want the approach. Just tell me what this question says to me. Fine. And just explain me the description part of this question. What we have to do exactly. Anyone who can help me with this?
Um, in this
Yeah.
question, we have been given a linked list with the
Mm-hmm.
cycle present.
Mm-hmm.
We have to first check if there is a cycle, and then we have to return the position to
Mm-hmm.
which the cycle is pointed to.
Okay, fine. So, you got it right, but Shraddha, right? Shraddha, you don't have to
Yes.
return the position.
Yes. Sorry,
You just,
I read it.
yeah,
Position nahi. We have to return true and false. That's all.
yeah, we have to return true and false. That's it. Fine. So let me start with the description, then I'll be starting with an algorithm which will be used in that question. Fine. So let's say I'm taking the first linked list. I have 320 minus 4. So let me draw that linked list. I have 3, and in the next of that I have 2 is minus 1, and that is 4. 3, 2, minus 1, 4, and 4 is being connected with 2 again. Fine. So what will I be doing? I'll be starting my iteration from this, which will be my head, and I won't be disturbing the property of my head. So I'll store the reference of my head in a variable of temp. Fine. So I have started my iteration, and in the next iteration, my temp will be here. In the next iteration, my temp will be here. In the next iteration, my temp will be here. And if you will notice, the moment when I'll be making my temp to the next pointer won't be null. Although 4 is my last node, 4 is the last node of my linked list. But sir, 4 will never point to the null. That means 4 is connected with someone else. And the moment when I'll be doing temp.next, my temp will come here at 2. And again, temp will be here, then temp will be here, and again, temp will be here. Temp, temp, temp. That means I'm not able to exit from this whole iteration. I'm not able to proceed towards the next step of my iteration. That means what I'm doing, if I'm having any sort of loop or cycle in my whole data set or in my data structures, that simply means I would end up doing the same thing again and again, again and again, and again and again. So if I'm doing the same thing again and again, I won't be able to find my answer. First, I won't be able to exit my iteration. Second, third, I won't be able to end my iteration. So I would end up killing my resources. Fine. So let's say there are X amount of things, X units of things, X units of resources which has been given to me, and the things are limited, the resources are limited, and I just have to complete the iteration and return an answer. But the resources are limited, and I'm just exceeding the limit of my resources by doing the same thing again and again and again and again. So this condition is being called as a cycle in that data set or a loop in that data set and a repetition of same instruction. That simply means, so I'm stuck in a case of loop. So now in this question, you have to figure it out that is there any cycle in your linked list? Fine. Let's say I have a linked list and in that I'm only having 3, 1, 0, and 5. So if you'll notice, I'll start my iteration from 3, I'll go till 1, I'll go till 0, and I go till 5. But after 5, my 5 is pointing to the null. That simply means 5 is my last node, 3 is my head node, and I have made in total 4 iterations. And I'm okay with that. I have used my resources in a very good way, and I just made 4 iterations and I got at the end of my linked list. But in the case of this linked list, I'm stuck in a case of loop. So what I have to do in this question, we have to find is there any loop inside my linked list or not? That's it. Fine. Now, what's the approach? If I'll be going with a condition, if I'll be going with two pointer approach, let's say I'll be putting a pointer at I and I'll be putting a pointer at J and keeping I at here and I'll be moving my J at every node. Fine. For I, 3 is the next of 3 is 2, the next of 2 is -1, the next of minus 1 is 4. So my I is here and J would be at every node and I won't be able to find a condition where my I is equals to J. In the next iteration, my I will be here, my J will be here, my J will be here, and my J will be here. The moment when my J will start from this pointer, I will get to know this thing, sir. I and J are referring to the same pointer again. If you got a possibility, if you will be having a chance of finding that two pointers are pointing to the same node, in that situation, I can say this thing, sir, I have a cycle in my linked list. But if I'll be going with this approach, I would end up writing a solution which goes in big O of n square. So how can I optimize it? How can I make it till big O of n? How can I optimize the given solution from n squared to n? Fine. So optimize this solution to optimize the current approach. There's an algorithm which is being called as Floyd cycle detection. Floyd cycle detection algorithm. Fine. So in this particular thing, let me just write the whole linked list 3, 2, minus 1, 4. What I'm doing, I'll be taking two pointers. The first pointer will be my slow pointer, and the second pointer will be my fast pointer. Fine. So as by name itself, you can guess this thing that what these pointers will gonna do. Slow pointer will be moving only one step ahead, and fast pointer will be moving two steps ahead. Fast is equals to fast dot next dot next. That means if my slow is here, in the next my slow will be here, but my fast will be at minus one. So till how I have to do this. So the condition is till my fast is not equals to null and the next pointer of my fast should not also be null. So what I'll be doing, I'll be needing a condition till when I'll be performing my iteration. So what I'll be doing, I'll be starting from my head. I'll move my slow pointer one step ahead and I'll move my fast pointer two step ahead. Fine. And at the end of my whole iteration, which will be revolving around a condition, and that condition is my fast should not be equals to null, and my fast dot next should also be not equals to null. So condition is I'm moving my fast, I'm moving my fast two steps at a time, and I'm making one step at a time with slow. So there would be a possibility my fast will reach at the last node before my slow pointer. So that simply means just put a condition that my fast should not be equals to null and my fast dot next should also be not equals to null. Fast भी null नहीं होगा और fast का अगला node भी null नहीं होगा. Fine. And now what I'll be doing, I'll just keep moving my slow pointer one node at a time, and I'll keep moving my fast pointer two nodes at a time. Fast dot next dot next. Let's say this 4 is connected with 2 and I have a loop in my linked list. Let's start. Initially my slow is here, my fast is here. Both slow and fast are referring to my head node. In the first iteration, my slow will be here, my fast will be here. In the next iteration, my slow will be here, my fast will be here. In the next iteration, my slow will be here and my fast will be here. And sir, if you'll notice one thing, the slow pointer and the fast pointer are referring to the same node. They both are pointing towards node and the value of that node is 4. I don't have to do anything with the value, but I just have to do with that as my slow and fast are referring to the same node. And if there is a linked list, sorry, if there is a loop or cycle in a linked list, there is a possibility of 100% that you would end up getting a situation where your slow and fast pointer are referring to the same node. So the condition is keep keep doing the iteration until fast and fast dot next is not equals to null. Move slow pointer one node at a time and fast pointer two nodes at a time. And if there is a cycle in a linked list, if there is a loop in a linked list, your slow and fast will be referring to the same node. And if at the end of the iteration, your slow becomes equals to fast, or at any part of your iteration, your slow becomes equals to fast, just return true. Otherwise, you what if what if आपको ये situation नहीं मिलती है? You're not able to find the situation where slow is equals to fast. At last, you will be returning false with specifying this thing that there is not a loop in a linked list. Guys, give me a thumbs up if I'm clear with this approach, with this algorithm. Is there anyone who's having any confusion? Please go ahead. Anyone जिसको लगा हो कि थोड़ा सा ऊपर से गया, थोड़ा बाउंसर गया, you can ask. Okay, fine. Let me take any other test case. Let me just refine all the things. Let me take a test case. Let's say I have 2, I have 4, I have 6, I have 8, I have 10, I have 11. And this 10 is being connected with this 4. Let's start. Condition should be my fast should not be equals to null. And please mute yourself. Yeah, thank you. And with that, my fast dot next should not be equals to null. I'll be moving slow one step. I'll be moving fast 2 steps. Fast dot next. Now, initially, both of the pointers will be at my head node. In the first iteration, my slow will be here, my fast will be here. In the next iteration, my slow will be here, my fast will be here. In the next iteration, my slow will be here, my fast will be here. In the next iteration, my slow will be here, my fast will be here. Now see, slow and fast are referring to the same node, are referring to the 10. That means I got a situation where my slow and fast are referring to the same node. That means there is a cycle in my linked list. I will return true. And if I won't be able to find a situation where my slow is equals to fast, I'll return false. Now give me a thumbs up if I'm clear with this question, if I'm clear with this algorithm. That is Floyd cycle detection algorithm. Shravya, do you want me to explain again after this also?
Yeah, it's a bit confusing, like how S will become equal to F.
Okay, so now see here. So what I have to do, Shravya, someone just joined. Okay, so what we have to do, Shravya, see here. What I'm doing, I'm taking 2 pointers. The first pointer, which will be my slow, and this guy will be moving one step at a time because it's slow. And I'll be having a fast pointer, and this pointer will be moving 2 steps at a time. Shravya, यहाँ तक clear है?
हाँ,
Fine.
clear है.
Now,
Yeah.
initially, Shravya, both of the pointers will be at the head of my linked list. That is from the first node. Fine. Now see here. In the next iteration, slow यहाँ पे आ जाएगा और fast यहाँ पे आ जाएगा because fast 2 कदम चल रहा है. Fine.
Yes.
In the next iteration, slow will be here and fast will be 1, 2. Here.
Yeah.
And if you will notice one thing, this 10 is connected with this 4. There is a loop in this linked list. So 10 के बाद 11 पे नहीं जाएगा. 10 के बाद this fast will be 1, 2. This fast will be here. And am I clear? Am I clear with this?
Yeah, yeah, got it.
And slow will be here. In the next iteration, my fast and slow both will be referring to the same to the node that is my 10.
So slow won't be going back in the same cycle, is it?
Slow will be going back after this 10, na, but on 10, I'm getting the situation where my slow is equals to fast.
Okay.
Fine. If there would be a possibility, Shabya, that at 10, I'm not having this situation. So the slow will also be moving here. After 10, it will be at 4. But before that situation, I'm getting the node where the cycle has been started. Fine. So 10 is the node where the cycle has been started. Fine. So
Yeah.
on this 10, I'll be getting a situation where my slow is equals to fast. And this is the situation of cycle in a linked list. Makes sense.
Yes.
Okay. So try to write the code or okay, do one thing. Let me write the first code, and the next question, for the next question, you will be writing the code by yourself. So what I have to do, I have to take two pointers. The first, both of the pointers will be of node type. So the node class is list node. So let's make list node, and the name of my first pointer will be slow, and it will be initially pointing to my head. Then list node fast is equals to, it will also be it will also be pointing to the head of my linked list. Now a while loop. So what I'm doing, I'm just moving my fast and slow. So there will be a case where my fast will be referring to null or will become null. Fine. So the condition is keep moving until your fast is not equals to null, and fast dot next should not also be equals to null. Move your slow pointer one step ahead and move your fast pointer two steps ahead. Fast dot next. And if at any particular iteration you got to know this thing, that slow and fast are referring to the same node, are pointing to the same node, that is the situation of a cycle in the linked list. So I'll be returning true. And let's say I haven't found any situation where my slow becomes equals to fast. That means I'm not a- I didn't able to find a cycle in my linked list, so I'll be return false. That's it. So let me just run it. Accepted. It's submitted. Fine. So that's how the Floyd cycle algorithm has been used, and we have found that there is a cycle in a linked list or not. That's it. Is there anyone who's having any kind of doubt? Please ask. I think the people who have I think just joined, or the people who are having their first class today, they would be having some questions. I think Ashish, am I clear with that? Are you guys clear with that? Mohit, Ashish, Ritvika, Akash. Are we on the same page, Mahesh? Are we on the same page?
Yeah. No problem. I'm not understanding. I'm getting it.
Okay, thank you so much, sir. Anyone else? Saurav, Shraddha, Shravya, Shrutika. Are we on the same page?
Yes,
Yeah,
yes.
it's clear.
Okay, thank you so much. Fine. So the next question, which is based on this algorithm only, there is a variation. So the next question is finding the middle of linked list. Let me just share this share this problem with you. Okay. Take 2 minutes and read this question. Okay, fine. Can we start? Anyone who can explain me the question, like what we have to do exactly? Anyone? Shraddha, Saurav, Palak, anyone who can explain me the
Yes.
question? Yeah,
Yeah, Nitin. We need to only return the middle node of the linked list.
that's it. That's it.
Yeah.
Fine. Okay, fine. Let's go with the approach which would end up taking more time. Fine. So I'm going with this 1, 2, 3, 4, 5. This is my head node, and I'm gonna use this algorithm here also. Floyd's cycle reflection. Every else thing will be same. That is, I will be taking 2 pointers. The first pointer will be my slow pointer, which will gonna move one step ahead, and I'll be having another pointer that is fast, and I'll be moving 2 steps ahead. Fine. Initially, they both will be on my head, but the moment either my fast dot next is equals to null or my fast is equals to null, I'll keep moving to the next node of my linked list. My slow will be here initially, and my fast will be here initially. This guy will be moving one step ahead. In the next iteration, my slow will be here, and my fast will be here. In the next iteration, my slow will be here, and my fast will be here. If you will notice one thing, sir, if I'll be moving my fast pointer one more time, either my fast will become null or my fast dot next becomes null. And if you'll notice one thing, the next pointer of my fast is null now. That means the while loop which I have been using to make this iteration, that will break. Because in my while loop, I was writing a condition, and that condition was, sir, my fast should not be equals to null, and my fast dot next should also be not equals to null. And these two conditions are in and a situation. That means both of them will be true. But the moment when I'll be at 5, this guy will raise his hands. That man इसके आगे तो अब null हो जाएगा, and I will not be able to make more iterations. My fast dot next is equals to null. That means one of the condition of my while loop gets break, and this whole will give me false. So the while loop will gonna break, and when that while loop breaks, the slow pointer will be giving me my answer. The node at which my slow pointer is right now, that will be my answer. Now see here. In the first iteration, my slow was here, then fast will be here. In the next iteration, my slow will be here and fast will be here. And fast dot next is equals to null. That means loop will break, and see, the place where your slow pointer is your middle node. The place or the node at which your slow pointer is, that is the middle node of your linked list. How should I believe on this with only one test case? Let me just go with another test case. 1, 2, 3, 4, 5, 6. I have 1, I have 2, I have 3, I have 4, I have 5, and then 6. I've started my iteration from 1. Slow will be here and fast will be here. In the next iteration, my slow was here and my fast will be here. In the next iteration, my slow will be here and my fast will be here. In the next iteration, my slow will be here and my fast will be at my fast will be at a node which is null for me, because fast will be 1, 2. Fast will be here somewhere. And this is my null. I don't have any node after 6. That means one of the condition of my loop will get false. That is, my fast should not be equals to null. This while loop gets break, and the place where your slow pointer is the middle node of your linked list. That is 4. Now, what I have to do, I'll have to make my iterations. I'll have to use this algorithm till either my fast is equals to null or my fast dot next is equals to null. If it is, the whole loop will gonna break, and the place where your slow pointer is, your slow pointer will be giving you the middle node of your linked list. Guys, give me a thumbs up if I'm clear with this problem. How to find the middle node in a linked list? Anyone who still have any confusion? Anyone? Shravya, Shraddha, Shrutika, anyone? Palak, Kriti, Noman, Mohit. Are you guys clear with that? Is there anyone else जिसको अभी भी थोड़ा बहुत कुछ चीज नहीं समझ में आई है? He or she can ask. Okay, fine. Take 4 minutes, take 3 to 4 minutes, and try to write the code for me. You don't have to do anything much. It's much similar to the previous question. The conditions will be same. You just have to do one thing. The place where this while loop gets break, return slow. Why don't we try it in a traditional method? Traditional method, that is counting the length and dividing it by 2. Mahesh, is it? Mahesh, is it? Sir, it will end up taking more time, and we used to avoid by covering the whole linked list because we would end up taking more time. Mahesh, am I clear? If you'll notice one
Yeah,
thing,
yeah, yeah.
Mahesh, if you'll notice one thing, I'm not making the complete length number of iterations. मेरी लिस्ट की साइज अगर 5 है तो I'll end up making 5 iterations, but with this concept I won't be able to make at least I won't be able to make even 3 to 4 iterations. Makes sense, Mahesh? So the whole story is revolving
Yeah, yeah,
around,
yeah, I'm getting it.
yeah, the whole story is revolving around decreasing the number of iterations, decreasing the number of steps so that I can optimize the solution. Make sense? Now try to write the code. You don't have to do anything. Just return slow when this loop gets break, and remove this slow is equals to fast wala condition. Take 2 minutes and write the code.
So,
Yeah.
sir, in this question, we have to return only one value, right? Only the
Mm-hmm.
middle value,
Yeah. Yeah. No, no. Let me correct you, Shraddha. Not
Hmm.
value, the node.
The node.
Yeah.
Um, sir, what would be the difference between the two?
Value is the data member of this node.
Yeah.
Fine. And node means it comprises of the reference and the value of that node. Makes sense.
Yes, sir, it makes sense. But
Mm-hmm.
जैसे for like this middle this linked list only 1 2 3 4 5. So
Mm-hmm.
3 is the answer. So it would return 3 only,
Yeah.
and value is also 3.
You're not getting my point, Shraddha. Let me just tell you by drawing something.
No, no, no.
Fine.
You're right that
Yeah.
we will have to return slow instead of just
Mm-hmm.
slow ka value.
Mm-hmm.
That would be the difference.
Mm-hmm. Yeah, exactly.
Okay, okay.
If I'll be returning slow, I would be
Hmm.
returning two things at a time: the difference of that node and the value of that node.
Yes, yes, sir, got it. And sir, इसमें क्या कहते हैं in the examples, in the output it has written a whole array of 3 4 5.
3, 4, 5. I'm not getting a point. Give me a moment.
In lead code question,
Mm-hmm.
the description part. Yes, yes, in the description part only. If you
Mm-hmm.
see the examples in the input and output part, in the output it has written 3 4 5. Yeah, here.
This one, 3, 4, 5.
Yes,
I
yes,
think
yes.
that's the some sort of uh क्या क्या बोलूं मैं इसको, maybe there would be
Glitch
some,
or
yeah,
something like that.
not glitch, Shraddha, right? Not glitch. It's just ये क्या क्या रहे हैं, they are finding the middle node and they are giving you the complete address of all the nodes. देखो basically होता क्या है, let me tell you in brief. Let's say if you'll be solving any question of linked list, let's say I have 2 3 4 5 6.
Hmm.
So in every question you will get to know this thing. They have already given you the reference of head. But why? Because head is having the reference of next node.
Yes, yes.
This guy is having the reference of this node, this
Hmm.
node, this node. So basically, if I would be giving you the head of a linked list, I will be having the reference of all the nodes. So basically,
Okay,
if I'm returning my middle node, that means I'm not returning my middle node. I'm returning these two guys also
okay, okay, okay.
because this
So
middle
it
is
would
having.
so it would return all the nodes after that value,
Exactly,
after that node.
exactly. So returning a node is very different with returning a value.
Okay, sir, got it. Thank
If
you.
you, yeah, if you're returning a value, you are returning only a single number. But if you're returning a node, you are returning the address of all the nodes which are being connected with that. Fine.
Yes, sir.
Yeah. How many
Thank you.
of, yeah, you're welcome. How many of you are done with the code? Okay, fine. मैं अभी फटाक से लिख देता हूँ. Give me a moment. A slow pointer which will be initially at my head and a fast pointer which will be initially at my head, while fast is not equals to null and fast dot next is not equals to null. Move your slow pointer one step ahead, move your fast pointer two steps ahead, and at last when this while loop gets break, return me slow. Then this submitted. Fine. Okay. Just give me a thumbs up if we are clear with the questions which we have discussed today. Both of the questions. I'll be starting with one more question, but the pattern will be same. You guys will be writing the code. I will just explain you the approach for that question. Fine. So the next question is the variation and the upgradation of this question. that is being called as linked list cycle. Fine. So the name of that question is linked list cycle 2. Now take a moment and